Welcome back. In this lecture, we'll understand how to actually create containers on your operating system. So basically, when I say I have multiple containers running on a particular operating system, what do I mean? Any application which is running within a container one should be completely isolated with the applications running in container 2 and container 3. Basically, what is advantage we get by running applications inside containers is we achieve isolation, and there are multiple types of isolations. For example, a process running in this container should be isolated from processes running in other containers. So what we might want is process isolation. The processes running in one container should be completely isolated from processes running in other containers. Also, I want each container to have its own Ethernet port or the network port so that they will be treated as individual isolated components, network related components. Normally, our machines, any machine will have a Ethernet port through which we do network communication, right? The traffic will go in and out through this network Ethernet ports. So basically, what I might want is I want a separate Ethernet port so that we feel like as if the container has its own Ethernet port through which the communications can go through. So basically, what I might want is a network isolation. So that means inside this container, as it is having its own Ethernet port, inside this container, if I have a process running on port 1, 2, 3, 4, on this container also, I should be able to run on another port 1, 2, 3, 4, 3, 4, because the Ethernet ports are different for each container, right? I want basically this kind of a facility where each container can have its own Ethernet ports, multiple, one or two or more Ethernet ports. And also, what I might want is the file system visible to the processes running in one container is should be different from the files available to other containers. So basically, I might want file system isolation. So there are different kinds of isolation, or maybe the host name for this container should be different than the host name inside this container. So I want host isolation as well. So actually, how do we achieve isolation on a Unix machine? So there comes a concept of a Linux kernel feature called as namespaces. By using namespaces, we can achieve isolation. So in this lecture, we will see how I can actually make process isolation, how I can actually make processes running on this operating system to be isolated, how to use process namespace, or we call it as PID namespace, PID, process ID namespace. So let us see how to actually create a process ID namespace so that one process will be totally unaware of other processes running on same operating system. Let us see. Basically, on any operating system, by default, there will be one default PID namespace or process ID namespace. So let's assume that this is your operating system. There will be one namespace, PID namespace. This is the default namespace at the operating system level. Similarly, there will be other namespaces also, like mount namespace, by using which we can achieve file system isolation. And also we'll be having something like control groups. It's also a namespace, C group we call, by using which we can allocate CPU or memory to a particular processes. And also we'll be having other namespaces like host namespace, default host namespace, and IPC namespace. Like that, there are multiple namespaces by default at the operating system level. So I'll show you. Actually, I am SSH'd onto the virtual machine by using this gcloud command. I have SSH'd onto this machine. I have shown you in the earlier video how to create this virtual machine on Google Cloud. I am SSH'd into it. Now, on this machine, if I want to see all the namespaces, I will use a command lsns. Sorry, lsns, list namespaces. See, these are all the various namespaces. Every namespace is identified by a unique ID. This is the identifier. So at the operating system level, there is a PID namespace or a process ID namespace, C group, user namespace, UTS namespace, IPC, mountain, and network namespaces. So how many? 1, 2, 3, 4, 5, 6, 7. 7 namespaces are there by default. Now, what I want to do is, I want to launch two processes, P1 and P2, within this default namespaces initially, and see how process P1 can see the process P2. Then I'm going to show you how to create separate PID namespaces to run process P1 in a separate PID namespace and process P2 in a separate namespace. First, let us start two processes inside default namespace. Okay. So what I will do is I have created my Git repository. Here is my Git repository for Docker training where I have some files. I will just go into it and clone that repository. By default on this VM, Git is installed. So I just use Git clone and then give my URL. Okay, so this will be cloned, and let me wait until it is done. Okay. So now Docker training is cloned. I'll cd into it. Now, if you see, there are two shell scripts, p1.sh and p2.sh. ls-l al, it will show me all. See, for this shell scripts and all, there is no execute permission by default, right? So I'll use chmod 777 star. So for all the files and all, now execute permission will be there. See, execute permission is now there. Okay, fine. Now let me show you p1.sh. See, what I am having is I initialized I equal to 0 and in a loop until 100. In a loop I am executing. For every time in the loop, I am making this process to sleep for 10 milliseconds. That's all. So 10 into 100, 1000 milliseconds. Sorry, it is seconds. Until 1000 seconds, this process will be running in a loop. That's all. Then I will show you. Wait. Then I will show you P2. There is p2.sh. Here, what I am doing is I'm initializing a variable file name with p2out.txt. Then I'm using a command pgrep. This will actually grep the processes. Pgrep the process with file p1.sh. So this pgrep command, if it is executed, it will give the PID, process ID of this process. So actually, if process P1 is running, its process ID will be initialized here. I'm checking if PID is existing. Sorry, if PID is 0, then I'm writing unable to find PID of P1 and I'm writing it to this file p2out.txt. Else If PID is there, I am writing PID of P1 is into same file. Then after writing this process also will sleep for 100 to 10 seconds. That's all. Now, let me run this processes. So first of all, if I use PS, there are no processes running except bash and this current process. Now what I will do is I'll execute dot slash p1 dot sh and I want it to run in background ampersand. Fine. Now if I see PS, I can see p1 dot sh and it is internally executing sleep command. Now I will launch p2 dot sh also. Now basically I am running both process p1 and p2 directly. So both of them will be running in the default process ID namespace. P2 will be able to see P1. Let us see. Okay, I started. Now if I execute P2 for PS, you can see P2 and P1 both are running. Fine. Now, if I do ls, is there a file with name p2out.txt? Yes, I'll just cat it. You can see that process P2 is able to list the PID of P1. What is the PID of P1? 15465. 15465. So do you remember in p2.sh what is the code? Here I am using pgrep to find the PID of P1. If it is there, then it is writing PID. If it is not there, if it is not able to find the process P1, then it is saying unable to find. Okay, but now this got printed. That means this process P2 is able to find P1. Why? Because by default, as I said, there will be a default PID namespace at the operating system level. When you launched P1, it is part of same default namespace. P2 also is part of default namespace. So processes in same namespace can actually see each other. Okay. So now how to actually launch both process P1 and P2 in different namespaces. Let us see. Step by step, I will show you. Okay. Now I will actually log SSH here and I'll just type PS. These processes are still running. I will kill them. Kill. What is the PID? 15465. 15465. And then again I'll kill 15471. Again, if I see PS, yes, both are terminated. Fine. Now I want to launch P1 in a separate namespace. How to launch a process in a separate namespace? There is a command. Command name is unshare. You don't want to share the same PID namespace or the namespace. Unshare hyphen p. Which namespace? Actually I showed you there are 7 namespaces. I don't want to share process namespace. Unshare hyphen p. And inside this unshare hyphen p will actually create a new namespace. Inside this namespace I want to fork a process called as bash process. So I will get the bash terminal. But again, I'm using one more thing which I'll explain you later. One more argument dash dash mount dash proc. You'll understand the meaning of this mount dash proc later. So this is a command to actually uh, launch or create a separate namespace, and inside this separate process namespace hyphen p, unshare hyphen p will say that I don't want to share the same process ID namespace. Right, that means it will create a new process namespace, and it'll fork this bash. Okay, we'll understand about dash dash mount proc later. Okay, bash. Oh, it is saying operation not permitted because to execute this unshare command, I need root permission. So I'll have to execute it using sudo. Okay, so now you can see that I got a different prompt root at because I executed using sudo. So now if I actually execute ps, you don't see anything except bash again. Now I will use lsns. This will actually show all the namespaces. Fine. Now let me open one more terminal. Let the terminal be there. I'll again take the gcloud command, copy, and in another terminal, I want to execute it so that I'll get one more terminal for the same machine. Let me get it. Yes. So there are two terminals right now. Yeah. See, you can see root at, that means I'm inside the bash shell in a separate namespace. So now on this again, the SSH machine, I use lsns. You can see the PID namespace is ending with 36. What is the PID namespace here? It is ending with 90. So now this bash is executing in a separate PID namespace ending with 90, but whereas this 836, the PID ending with 836 is the default namespace. Actually, we created a separate namespace only for PID. Whereas you can see C group namespace, it is ending with 835. Here also it is 835. User namespace is 837. This is 837. UTS namespace 838. IPC namespace is 839. Here also it is 839. Like that, all the other namespaces are same except PID namespace, which is ending with 90, and mount namespace, MNT stands for mount. This also is different. Actually, I said to unshare only -p, right? Only a new process namespace could have been created. But why a separate mount namespace also is created? Because I used another thing called as dash dash mount dash proc. We'll understand about what is this mount proc later. But as I use this option, a separate namespace, mount namespace also is created. Now here, if I run any process, it will be running in this bash terminal. If I run any process, it will be running as a child to bash process in this namespace. So here I will execute /p1. Okay, here p1 is running. Now I could have ran it in the background. I'll press Ctrl C ls. Sorry, ps. Yeah, it is terminated. That's fine. Now what I'll do /p1.sh ampersand. So it will run in background. That's okay. Now here if I see ps, I don't see this process, right? Here if I use ps, I'm able to see p1.sh, but in the default namespace, I am not. I will use ps-a. Sorry, ps-a to show all processes. Oh, here in the parent namespace, I can see p1.sh. The PID is 15701. But on this child namespace, it is actually 19. So basically, let me explain you. Now what you have is two namespaces. Parent namespace. This is your operating system. You have a parent namespace. Uh, what is the parent namespace? What is the PID of this parent namespace here? 836, ending with 836. This is one parent namespace. And there's one more namespace which I created. I will in the child namespace lsns I will write. What is the PID? Ending with 290. ending with 290. So this 290 is the process ID for the process namespace, PID namespace. 290, yes. Now in this namespace, I have launched P1, which has a PID of what? 19. The PID is 19. Actually, the processes launched inside child namespace will be visible to the parent namespace, but the PID will be different. What is the PID of this P1? What is the PID of P1? It is 15701, right? Here 15701 actually represents this process P1 running inside the child namespace, but it is given a different PID. So remember, the parent namespace can always see the processes in the child namespace, but the process ID will be different. Okay. Now what I want to do is I want to launch one more process namespace and see whether I'll be able to actually say this P1 in this namespace. So what I'm going to do is again in the left side terminal, again I will execute the same command sudo unshare -p. I want to separate unshared process namespace and I want to fork bash, and also I'm using dash dash mount dash proc. We'll understand mount dash proc later. This will create one more process namespace and I'm running bash terminal inside this. Now if I do lsns, I'm inside a separate namespace. Sorry, lsns. See here the PID namespace is ending with 292. This is 290. So we launched two PID namespaces. Now if I write ps dash a here, sorry, ps dash a, I'm able to see p1.sh in this namespace. But from this namespace, if I write ps dash a, am I able to see? No. So the processes running in this namespace will not be able to see the processes running in this namespace, right? So we have process isolation. These processes running in this namespace and the processes running in this namespace are completely isolated. Processes running in namespace 1 cannot see processes running in namespace 2. Let us test it. So what I'm going to do is again here, I'll write ps dash a, p1 is still running, and here I will launch p2. I'll cd into docker training folder. Yeah, I launch p2 dot slash p2 in a separate namespace. Now let us see this p2 out.txt cat p2 out.txt, which is written by p2.sh, unable to find PID of P1, right? This file is written right now. So the process P2 running in this namespace is not able to find P1, right? So that's how actually you can create a separate process namespace. Hope it is clear. Remember, from the parent namespace or the default namespaces, a default namespace can see the processes running in both these namespaces. Okay, but the process running in this child namespace cannot see the processes running in this child namespace. So we understood how to launch processes in two different namespaces. Don't worry, slowly we'll build on this. If required, I recommend you to again watch this video to understand the concepts. Till now, we have not completed building our own containers. Just we understood about PID namespaces. Once we understand about other namespaces also, we'll see the complete container, right? So that's about process isolation, how to launch processes in separate process ID namespaces. In the next lecture, we'll see what are these mount namespaces, and we'll also understand about mount dash 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 mount proc also in the next lecture. See you in next lecture.